Good evening. Now I will be sharing my slides. Hope the slides are visible. Good evening all. Welcome to week 3 tutorials of NPTEL PMRF tutorials of the course Pericyclic Reactions and Organic Photochemistry by Professor S. Shangaraman from IIT Madras. Myself, Anisha Suresh, PMRF TA for this course from IIT Bombay. So, in the previous week, we were discussing regarding electrocyclic reactions and then cycloaddition reaction. So, in this week, we have continued cycloaddition reactions um, and we have discussed regarding 1,3 dipolar cycloaddition. So, along with some higher order cycloaddition reactions. So, I will be discussing few questions based on Diels-Alder reactions, dipolar cycloaddition reaction, and this higher order cycloaddition reaction. So let us go to question number 1. So coming to question number 1. The major product formed in the following reaction is. So here two components are given. It is treated with ZnCl2 at RT. So what is the product that is formed? So four different options have been given and we have to choose the correct answer from among these four options. So which sort of reaction is this? As we can see, this is a 4 pi component and this is a 2 pi component. So this will be a 4 plus 2 cycloaddition reaction. So this is the 4 pi component and this is the 2 pi component. So we know that in a typical Diels-Alder reaction, the diene is electron rich component and the dienophile, that is the 2 pi component, is the electron poor component. So we can see that here there is an electron withdrawing group. Because of that, this sender will be electron poor. And because of this like electron releasing methyl group. Uh, so this methyl group will be electron releasing in nature. Because of that, this sender will be electron rich. So this reaction will be taking place in this fashion. So this will be adding on to this and this will be adding on to this and this double bond will shift to here. So this will be the product. So we can rule out the options like this one and this one. Okay, electron rich sender should react with the electron poor sender. So the orientation will be in this fashion. Hence we can rule out the option 3 and option 4 option. Okay, option 3 and option 4 could be ruled out. Now among 1 and 2, which will be the desired product, that we will see. So this we have seen that electron withdrawing groups on the dienophile will facilitate the reaction. So CO2 is on the dienophile. So that will make the sender electron deficient. Hence the electron rich. Hence the electron rich component should um, sorry, there is one correction. Because of the presence of this O-benzyl group. O-benzyl is electron releasing in nature. So because of that, This group is also electron releasing in nature, and compared to medial group, it is uh, more electron releasing. Hence, this sender. So I think there is a mistake in the options that I have given. So this is not the right answer. The orientation should be in such a way that um, the CO2 ET will be coming in this direction, and this is the electron poor component. So this electron poor component will be reacting with the electron rich sender, which is this one. So the reaction will be taking place in this fashion. So this will attack on this and this will attack on this. Okay, so this is not the right answer. And the approach will be in endo fashion, so we will get the desired product like n tosyl, and here there will be, so this will come in the alpha direction, and there will be a double bond. This will also be in the alpha side. So this is coming in the endo direction, because of that it is alpha, and since it is facing away from the diene, this will also come alpha. So the right answer will be option 1, not option 4. Option 1 is the right answer. Okay, so this is the electron rich sender of the diene, and this is the electron deficient sender, electron poor sender, because of the presence of the CO2 ET. Hence this will be the right answer. Okay, now coming to the second question. The major product formed in the following reaction is. So here there is a nitrogen containing three-membered ring is given, and phenyl substituted acetylene is also given. So it is subjected to thermal condition. So what is the reaction that will be taking place? So this is highly strained ring. It will open like this. So this is a 4 pi electron system, 4 electron system. This is a 4 electron system. So 4 electron under thermal condition. What will be the reaction that will take place? What will be the mode of ring opening? Conrotatory or disrotatory? So 4 electron system under thermal condition, it will undergo conrotatory ring opening. Okay, 4 electron system conrotatory under thermal condition. So if it is open in conrotatory fashion, if this CO2 CH3 CO2 Me is going inside the ring, inside this system, this will be going away from the system. So what we will be getting is CO2 Me, CO2 Me like this, plus minus. So this is the dipole we will be having, and this is the dipolar of phi. So the dipole will be reacting with the dipolar of phi, and we will be getting one among this products. So what will be the product that we'll be getting? So we can eliminate these options 3 and 4 because it is showing rearranged pattern of this dipole. So this will be reacting with the dipolorophile in this fashion. So we will be getting a 5-membered ring like this. This will be pH, pH, and this CO2Me. This CO2Me is in trans fashion. One is coming inside and one is going outside. So these are in trans fashion. So the right option will be option 2. Option 2 will be the right answer. You can see like this. Ring opening will be taking place under thermal condition to give this 1,3 dipole. So this 1,3 dipole will undergo a 4 plus 2 cycloaddition based on the number of electrons. So number of electrons will be 4 plus 2. So it will undergo a 4 plus 2 cycloaddition reaction. And since one of the CO2Me is inside, this is inside and this is outside. So we will get the CO2Me in trans fashion. Okay. So the right option will be option 2. I hope this is clear. Now coming to question number 3. So we are having a 7-membered system having an oxygen. So this is a 4n plus 2 electron system. So it can undergo electrocyclization reaction leading to formation of this compound A. So 1, 2, 3, 4, 5, 6. A 6-membered ring attached to a epoxide. So and then this B and A can react with this malic anhydride leading to formation of this product PP and PA respectively. So we are asking, so four energy diagram have been given. Four energy diagram have been given. So out of this, what is the correct energy profile for the above reaction? So out of B and A, which will be having greater energy? So out of B and A is unstable because of this presence of this epoxide, which is little strained. So A will be unstable. If stability decreases, energy will be increasing. Stability and energy are inversely related. So if stability decrease, energy increase. So A has more energy than B. So out of this given options, which represents A having more energy than B? So in this case, A is having less energy than B. That we can rule out. Here A is having more energy than B. Here also A is having more energy than B. Now this is unstable. This is unstable, hence it can easily react with this dienophile, giving this 4 plus 2 addition product. And since it is a fused system, as it is a fused system, the cis conformation will be fixed and the reaction will be taking place in a faster rate. So A to Pa, this reaction rate will be faster. So the activation energy here will be lesser. And this B, it is a seven-membered ring. Seven-membered ring, it can have, so it is free to flexible. The seven-membered ring is flexible. Hence, this reaction, that is the 4 plus 2 reaction that is taking place here to give the Pb will be taking place at a slower rate. The activation energy needed for this reaction is much higher. So, the activation energy for formation of B to Pb is higher. Activation energy higher. Here, activation energy lower. So as we can see, in this case, the activation energy is given higher. So this is a wrong option, and in this case, the activation energy is given lower and here higher. In this case also, the activation energy. So we can see here, this is the activation energy. So in this both cases, the activation energy for formation of Pa to Pb is shown lesser. In this case also, in this case also, and the energy of Pa will be greater than that of Pb because of the presence of the strained ring. Hence, right answer will be option 3. As we can see, out of A and B, compound A is less stable and more reactive. That is, this is less stable because of the presence of this three-membered ring, and hence, since it is less stable, it will be more reactive as well, and the schizoid conformation here will be fixed, and the reaction rate will be more, so the activation energy will be lower. The higher reactivity towards a dienophile can be explained by the following reason. The compound A has smaller ring and thus it acts as a more rigid cis-diene. That is, the cis-diene will be fixed and hence it can react faster with the dienophile. While compound B is a 7-membered aromatic ring, bigger rings are more flexible. Therefore, compound B will have lower reactivity towards a dienophile. Compound A is reactive, the activation energy will be lower for the formation of Pa. And since because of the presence of that three-membered ring, the product Pa will be having little higher energy than that of the product Pb. So the correct energy profile diagram will be option 3. I hope this is clear. So the factors that we have to take into consideration is as stability decreases, energy increases, and as rate increases, activation energy decreases. Okay, these are the two factors that we have to keep in mind uh, while seeing the energy profile diagram. Now coming to question number 4. So this is a question based on cycloaddition of higher electron systems. So the following transformation. So this is a 1, 2, 3, 4, 8 pi electron system, and this is the uh, dienophile that will be acting here. That is the benzene. So this is a 2 pi electron system. So these two will react giving this product. So they are asking if this is an example of what type of cycloaddition reaction. So acetate 3 pi 2 pi cycloaddition reaction, 6 pi 2 pi cycloaddition reaction, 8 pi 2 pi cycloaddition reaction, or a 8 pi 4 pi cycloaddition reaction. So as we can see, this is an 8 pi electron component and this will be acting as a 2 pi electron component. So this will be an example of 8 pi 2 pi cycloaddition reaction. So the benzene, it is a very reactive species. Normally the triple bond used to be linear in nature, but in case of benzene, the triple bond is non-linear and hence it is very reactive species. The given conjugated unsaturated system undergoes cycloaddition with benzene as follows. So this is a conjugated unsaturated system. It can react with benzene involving all the 8 pi electrons. As we can see here, the benzene will add to here, this double bond will shift here, this double bond will shift here, this double bond will shift here, and this double bond will go and attack on the benzene, leading to formation of this system. And since it is an 8 pi 2 pi system, this will be 4n plus 2 kind of system. So the reaction will take place in suprafacial manner. So both of this starting materials will react in superficial manner. Because of that, these two hydrogens are coming in the same side. 8 pi electrons of bicyclic conjugate system are involved in cyclization with 2 pi electrons of the benzene system, and this stereochemistry of the hydrogen is determined by the suprafacial reaction of these two components. So the reaction is 8 pi 2 pi cycloaddition. The correct option will be option number 3. Now coming to question number 5. So here, what is the major product that is formed in the following reaction? So this is a Diels-Alder type of reaction. So as we have seen in the first question, Diels-Alder reaction take place between a 4 pi electron component and a 2 pi electron component. So this is the diene and this is the dienophile. So here this is the diene component and this is the dienophile, and we have seen the normal Diels-Alder cases. The diene is electron rich in nature and the dienophile is electron poor in nature. So this cyano group, it is an electron withdrawing group. It makes this sender electron poor, and this methoxy group, OMe group, it is an electron releasing group. So it will release the electrons in this fashion and it will make this sender electron rich. So the electron rich sender and the electron poor sender will be reacting to give the Diels-Alder adduct. And after Diels-Alder reaction, it is treated with aqueous acid, and what will be the product that we will get? So we will see the mechanism in detail. So as we have discussed, two possible orientations or arrangements are possible. So the diene and dienophile can react in, sorry, this is the diene. So the diene and dienophile, they can be oriented in this fashion or in this fashion. So this is the electron donating group and this is the electron withdrawing group. So this sender will be electron poor and this sender will be electron rich. So this senders will be reacting and we will be getting the product from this orientation. This orientation will not give any desired products. Okay, as we can see here. So when we are writing it in ionic form, which is not the actual representation, we will get the nucleophilic diene here and the electrophilic dienophile here. So the nucleophilic sender will be reacting with the electrophilic sender for giving the product. So the reaction will be taking place in this fashion. And now we are treating it with aqueous acid. So this OMe will be getting protonated, and the Cl will be taking this SiMe3, as it is this halides will be liking silicones. So this bond will break and this will shift here. This double bond will shift here and the methanol will be eliminating. So we will get a ketone here and a double bond here. That is an enone will be generated and the cyano will be remaining without any uh, effect from acid. So this is the product that we will get in the reaction that was given in the question. This orientation is not favored because this is the electron poor center and this is the electron rich center. So reaction like this is not favored. So this product will be not formed. So the right option will be option 3. So the right option will be option 3. Is this clear? Now coming to question number 6. So the following transformation involves a series of. So here we have been given a dipole and a dipolorophile, and at heating condition they have shown CO2 will be eliminating. So it what sort of reaction is taking place here? Is it electrocyclic ring opening and closing reaction? Is it like cycloaddition and cycloreversion reaction? Is it a sigmatropic rearrangement? Is it a chelotropic addition and elimination reaction? So the right option will be what? So we will see the mechanism of the reaction and we will conclude what is the sequence of reaction that is taking place here. So we can see this is the dipole, 1,3 dipole that will be participating in the 4 plus 2 cycloaddition reaction. 4 plus 2 cycloaddition based on the number of electrons. Okay, if we consider the number of atoms taking part, it is called as 3 plus 2 cycloaddition reaction. So the reaction proceeds through the following mechanism. So this will add on to this will add on to this, and this positive charge on nitrogen will be neutralized. So we will get a system like this, where this O double bond O, this will be coming in a bridged fashion. So the angle, 120-degree angle of CO2 is not maintained, and because of that, the CO2 will undergo extrusion. So extrusion will be taking place in this fashion. This lone pair on nitrogen will shift in this direction. The CO2 will eliminate, and there will be a negative charge generated here. So this step is known as cycloreversion reaction, and this step is known as cycloaddition reaction. Either we can say it is a 4 plus 2 cycloaddition reaction based on the number of electrons, or a 1,3 dipolar cycloaddition reaction, since this is a 1,3 dipole and this is a dipolophile. Or we can say it as a 3 plus 2 cycloaddition reaction based on the number of atoms that are taking part in this reaction. And this elimination of CO2, this step is known as cycloreversion reaction. And now again a dipole is generated here. So this is the negative center, this is the positive center. Again a dipole is generated and we have a dipolorophile in the system. So this will add on to the alkene, and this alkene will go add on to this nitrogen, and this positive charge on the nitrogen is neutralized, and we will get this system. So this can be written in this fashion, which was given in the question. So what is the sequence of reaction taking place here? The reactions that are taking place in this sequence in this reaction is a cycloaddition reaction, a cycloreversion reaction, and again a cycloaddition reaction. So two 1,3 dipolar cycloaddition reactions are taking place here. Okay, so the correct answer will be the cycloaddition and cycloreversion reaction. So this following transformation involves a series of cycloaddition and cycloreversion reaction. So the right option will be option 2. Now coming to the seventh question. Here they have given cyclopentadiene is reacting with acetylene at room temperature to give compound A. So we know this is the structure of cyclopentadiene and this is the structure of acetylene. So they are reacting at room temperature to give A. So this is a dipole, sorry. So this is a diene and this is a dienophile. It will undergo a 4 plus 2 cycloaddition reaction, that is a Diels-Alder reaction, to give a compound. So I will this could be written like in this fashion. Two double bonds will be there. Okay, this will be compound A. Now having compound A in hand, the compound A is reacted with hexachlorocyclopentadiene. Hexachlorocyclopentadiene means this one. Cl, 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 Cl. So this will act as the diene and this will be acting as the dienophile and we will get compound B. So compound B is aldrin which is used as a pesticide. So what will be the structure of A and B? So now this diene will react with this dienophile and we will get this product. So this is the diene and this is the dienophile. It will undergo Diels-Alder reaction and we will get this product. Okay. So first Norborna diene will be forming by reaction of cyclopentadiene and acetylene and this Norborna diene will be acting as the dienophile and this hexachloro cyclopentadiene will be acting as the diene in this case and we will get this aldrin. So I hope the mechanism is clear. Now coming to the eighth question. Complete the following reaction. So an acid chloride is given and it is treated with triethylamine. We get a compound A and it is treated with this alkene, nitrogen containing alkene, and we will get a compound B. So what will be the first reaction that is taking place? The first reaction that will be taking place is formation of ketene. So what will be the mechanism? So first, triethylamine, it will be abstracting the proton that will be alpha to that of the acid chloride. Okay, this proton will be abstracted. This bond will break, this will shift to here and this will generate an enolate and this enolate, once it is falling back, this Cl will be removed and it will result in the formation of this ketene. Now we are having this ketene and this is the alkene we are having. So it will undergo a 2 plus 2 cycloaddition reaction resulting in the formation of this amide, cyclobutane amide. Okay. This bond will react here and this will react here leading to formation of this amide. Is this clear? So the first important thing is we should understand the formation of the ketene, and once we are having the ketene in hand, it will undergo a thermal 2 plus 2 cycloaddition reaction resulting in the formation of this four-membered lactam, beta lactam. And the ninth question is nitroalkane undergoes dehydration reaction with this phenyl isocyanate to give nitrile oxide. Keeping this in mind, complete the following reaction. So this is a 1,3 dipolar cycloaddition reaction. So we know that, and we have seen in the lectures that in the presence of this phenyl isocyanate, this nitrile group will undergo a dehydration reaction resulting in the formation of nitrile oxide. So that nitrile oxide will be compound A, and that compound A, nitrile oxide will be acting as the 1,3 dipole, and this will act as the dipolophile, and it will undergo a 1,3 dipolar cycloaddition reaction resulting in the formation of B. So what will be the mechanism for that reaction? So we can see here that this is the nitrile group. So in the presence of phenyl isocyanate, it will undergo dehydration, that is elimination of water, leading to formation of this nitrile oxide. So this is the 1,3 dipole, and this is the dipolorophile. So this dipole will add on to this dipolorophile in this fashion, leading to formation of this adduct. An intramolecular 1,3 dipolar cycloaddition reaction will be taking place, leading to formation of a 5-membered ring here. Okay, oxygen will attack at this position, and this double bond will go and attack on this carbon, neutralizing this positive charge, leading to formation of this 5-membered cycle. So here a two-ring formation will be taking place since it is an intramolecular cycloaddition reaction. Is this clear? Now coming to question number 10. Benzocyclobutane, that is this one, reacts with malic anhydride when heated at 200 degrees Celsius to give this single product. So this single product is formed when this benzocyclobutane is reacting with malic anhydride. So we have to write the mechanism of this reaction. So first of all, this reaction will be undergoing through two steps. First, there will be an electrocyclic ring opening of this system, leading to formation of a diene, and that diene will undergo a Diels-Alder reaction with this malic anhydride, leading to formation of this product. So first what will be taking place is an electrocyclic ring opening of cyclobutane, as we can see here, leading to formation of this diene. So this diene will react with this malic anhydride. So we can see this will add on to this will add on to this, and a double bond is formed here, leading to rearomatization, and this product is formed. Is this clear? And this hydrogen will be beta, since the cycloaddition will be taking place in endo fashion. Now question number 11. Predict the product for each Diels-Alder reaction. Indicate the stereochemistry where appropriate. So this is the diene, and this is the dienophile in this case. In option In the question number A, this is the diene and this is the dienophile. So a normal Diels-Alder reaction will be taking place in this fashion, in a concerted fashion, leading to formation of this classical cyclohexene. And in the second case, we are having a disubstituted diene and this dienophile. So this dienophile is trans. So this trans stereochemistry will be maintained in the product. Okay. So this will add on to this. This will add on to this and a double bond will be formed here. CH3, CH3, and this, if it is beta, this will be alpha. So this will be coming in endo fashion. Hence, this can be written like this will come alpha and this will be beta. And now we are having this as the dienophile and this as the diene. So it will react in this fashion, leading to formation of this product. So these are simple examples of Diels-Alder reaction, just to make clear that Diels-Alder reaction is thorough with everyone. Okay, and just do numbering so that you will not write the substituents in different side. This could also be written, or as we have written, CHO could be here and CH3 could be here. So just we have to keep in mind that since this is trans, it will be maintained in the product. So this will become trans. Okay. Now coming to our last question. So this is based on retro Diels-Alder reaction. We have to predict what is the starting materials that lead to formation of the Diels-Alder adduct. So this is the Diels-Alder adduct we have got. We have to show what is the combination of the diene and dienophile that will result in formation of this Diels-Alder product. So this is the cyclopenta. So this is the cyclohexene ring that is formed. See, this is the cyclohexene ring that is formed. So if we do a retro Diels-Alder reaction, we can draw the product starting materials that have lead to formation of this diene and dienophile. Okay, and this is another Diels-Alder adduct. Here also we have to predict what are the starting materials that lead to formation of this product. So here we can see this could be written in like this fashion. Okay, this can be written in this fashion, showing the cyclohexane. So showing this cyclohexane clearly. Now what we will do is we will sorry. So which are the new bonds that have formed? These are the new bonds that have formed in Diels-Alder reaction. So these bonds will be breaking. So that will lead to formation of the starting materials. So the starting materials will be a cyclopentadiene and a parabenzoquinone, as we can see here. And in the other case, there is two bridgeheads. As we can see, there is two bridgeheads. Now These are the new bonds that have formed upon Diels-Alder reaction. If we draw it like in this fashion, a six-membered ring is forming. So that if we are drawing in this fashion, these are the two new bonds that are formed. So those bonds will be breaking. So we will get a cyclohexadiene and this dialdehyde substituted acetylene. So these are the two starting materials that lead to formation of this adduct. I hope whatever we have discussed, whatever questions that we have discussed so far is clear to everyone. So if you are having any doubts, you can ask in the comment section of the video that I will be uploading into YouTube. So for additional information, I just have to show how this nitrile oxide is forming by reaction of nitro compound, that is nitrile with phenyl isocyanate. So what will be happening here is this negative charge of the oxygen, it will go and add on to this carbon. So this double bond will break, it will go leading to formation of O minus, then it will come back, then this double bond will go and abstract this proton and a and this bond will break leading to formation of a double bond here. So this type of a system will be forming. Now what will happen, a CO2 elimination will be taking place and a PHNH2, a phenylamine will also be eliminating leading to formation of this nitrile oxide. Okay. If you are showing stepwise mechanism, it will be like this. If you are having any doubts, you can ask. So thank you for your cooperation. If you are having any doubts regarding any of the questions that we have discussed today, you can post in the YouTube comments of the video I will be uploading today. Thank you for your cooperation. Thank you so much.